if n is a positive integer, is the units digit of n equal to a 0? And so what does that mean if we have a units digit of 0? So what are some numbers with a units digit of 0 if we are looking for patterns here? So 10, 20, 30, 40, 100, we can say, right? 500. 650. These all have units digits of 0. And what do they all have in common? So these are all multiples of 10, right? So another way we can think of our question or rephrase our question is n a multiple of 10? So this is sort of a divisibility question that is disguised as one of these units digit questions, or maybe even an exponent question. But that is why I say divisibility is really the singular most valuable subject to know and understand on the Gmat, because it connects everything. Statement 1, 14 and 35 are factors of n. So we want to know, is n a multiple of 10, which also means does n contain a 2 and a 5, right? Are 2 and 5 factors of n? So if n, so we don't know that these are all of the factors of n, but we know it's got to contain at least both of these things. And so if we break both of these up, so we know n has got to contain a 14, which is really just a 2 and a 7. And then we also know it's got to contain a 35, which is just a 7 and a 5. But we already have a 7, right? And so this doesn't mean it's got to contain 2 7s. We can still use this 7 over here to make our 35. So all we really need is our 5. That doesn't mean it doesn't contain 2 7s. And so we can say there are other factors here, and we can represent all of those just by saying x if we want. But we know at a minimum, n has to contain these two things. And so we want to know, is n a multiple of 10, or does it have factors of 2 and 5? And here we got both of those. And so this is actually sufficient to say yes to our question. Statement 2, n equals 2 to the 5th times 3 squared times 5 to the 7th times 7 to the 6th. And so we're looking for a 2 and a 5. Well, we got plenty of 2s here. We only needed 1, and we have 5 of them. And then we have even more 5s. We got 7 5s, and we only needed 1 of those. And so this is also sufficient without really doing much work. Another way you can think of this, if you don't rephrase your question in terms of, is n a multiple of 10? Well, if all you're looking for is the units digit of n, then you should only care about the units digit of each of its factors, or each of these terms here. And so 2 to the 5th is 32, which has a units digit of 2. So you can think, if I'm just looking for the units digit here, so this isn't what n's is equal to, but we can say n's unit digit is going to be equal. So 32 has a units digit of 2. 3 squared is 9. 5 to the 7th, I don't know what that is, but I know 5 squared is 25. And so then if you multiply that by 5, you're just going to get another units digit of 5. And so 5 raised to the anything is always going to have a units digit of 5. Same is true for 6, I believe, right? 6 raised to the anything is always going to have a units digit of 6. And then we got 7 to the 6th here. And again, I don't know what 7 to the 6th is, but I could find what its units digit is pretty easily. So 7 to the 1st is just 7. 7 squared is 49, which has a units digit of 9. 7 cubed, I don't know what that is, but I know 9 times 7 is 63, so this should have a units digit of 3. And then 3 times 7 is 21, so 7 to the 4th should have a units digit of 1. And then once you get to here, so once I multiply 1 times 7 again, this pattern is going to repeat. So 7 to the 5th should have a units digit of 7 again, and 7 to the 6th should have a units digit of 9 again. So if I'm just looking for the units digit of this number, so 9 times 9 is 81 times 5 times 2. So 5 times 2 times 1 should have a units digit of 0. And so again, that's still sufficient to answer yes to our question, just the original question, not our rephrased question. So either way, D is the answer.